we have here is this toggle switch allows me to select between two different igniters, or what do you want to call it. Can't do it with one hand, sorry. That or that. Golly, it's a tough switch. Anyway, the way I've got it hooked up is to the center leads. I hooked up the feed from the ECU. That's the trigger for the ECU. Okay, and on the other side of it, I have the lead that goes to the negative lead of the coil. Okay, so that's your two things. I decided I want to have isolate two connections, not just one, just to be safe. It wasn't somehow the two igniters would fight each other. So, coil negative signal wire. Now this one right here, this pigtail here, it goes back to that I think it's called a PRW-2 unit. That sounded like a Nissan. So the blue wire is what's supposed to go to the coil. So as you can see, I've got it hooked up on this side. So it goes from here to the brown wire when it's switched in that direction. And the trigger lead, which also goes to PRW2, that's this yellow white one, it goes to there. So basically that was the original connection. Okay, that yellow and white wire was one wire, and I just clipped it and connected it between these two pieces. This blue wire used to go to the coil directly. Now it goes to the coil through that brown wire. All right. So that's one circuit. So when I have the switch clicked that way, okay, I'm running on that thing. Now the other circuit, you see this white wire here? That's a trigger wire that goes back to this transistor unit. I hope you can see this. Let me see if I can get in there. I don't know. It's probably too dark. I'm trying to see what you're looking at here. Yeah, well, anyway, there's a transistor unit back in there. You can kind of see it there. And it has a T connector. One of the T's is the base of the transistor. So that's where the trigger wire goes to it, and its output is on a blue lead right here. Comes out from underneath the transistor unit, right? Like I said, you're not going to be able to see because of the darkness. Sorry about that. So anyway, why did you do all this stuff, Dave? Well, I wanted to have two independent triggering units just in case that could account for the odd behavior I've had with this intermittent cut. So today, first of all, I test ran it, and you can toggle that switch back and forth. There's no center position, so it's either one way or the other. So it's so fast when you click from one igniter to the other igniter, it has no effect on the running of the unit. So you could just back and forth all day long. It doesn't affect it at all. It doesn't miss a beat. So that's that, okay? And my idea was if there was something going on with my junkyard igniter, which is what that PRW-2 is, if somehow that was causing some issues, I wanted to have another junkyard pull the transistor unit. So I could just toggle it. So if the engine started to die, I'd toggle it. If it died completely and would not restart, I'd go toggle and try to restart. So that's kind of like the cheap way of doing a test rather than a proper waveform analysis. So what? Anyway, I ran the engine today for probably 45 minutes, and it didn't miss a beat. I mean, it just ran perfectly normal. I stopped it. It'd start right back up again. I never had the issue. So it's running great. No issues whatsoever. Temperature went right to 165. Stopped. Last time I did it, it had to go 185. Then it kicked in and worked. So I don't know. Maybe it had to burp some air out. Now it works much better. It just goes to 165 and immediately stops there. So I don't know. That's not this. I was not able to test anything. Now, forgot the other variable besides the reason I put that in was to take a variable out. I could switch over to a different igniter. The other variable was the distributor I'm running. Okay, that's Jeff's distributor. That's his junkyard pull from his one. Now that was the one I did some waveform analysis on. And the waveform was different and the same. When you spun the distributor, it looked very similar in waveform on the spark spark plugs, not the 360, but the 60-degree ones. And when there's 6 slots in there, if you spun it fast, it kind of looked the same. If you recall, it had a negative going, kind of a sawtooth looking square wave, a square wave with a sawtooth look on the top of it. I don't know if what that was all about. The 360-degree one looks much cleaner, much like a more normal looking square wave. But that 60-degree one was a little funky looking and it was very weak. But it was very weak on my distributor and it was very weak on Jeff's distributor. Jeff's distributor might have had a little bit more, but not much. And I'm talking about weak. I'm talking a 20 millivolt signal, whereas the 360-degree one was more like 1 volt square wave. I don't know why that is, but whatever. It just seems to be running fine with that. I mean, just to me, with a 20 millivolt signal, man, you get some noise, anything could come over there and just blow that out. But, you know, it never missed a beat. The other thing that was weird about Jeff's was when you slow it down and you got on this one slot, the signal would go positive and then come back. Whereas when you slowed mine down, it got on an open slot. I mean, really slow. The signal will go a little bit negative. Again, it was when you spin it at kind of normal speeds, they look similar, but they were not behaving the same. So I don't know what was up with that. But anyway, it never missed a beat with Jeff's distributor. So I think what I'm going to do next, for the next test, is I'm going to find the pins. I think it's like number 8 and number 16 in here. I'll find them. I'll back probe them. I'll get some fine wire and back probe the thing, and then I'll get my scope. And I'll use both channels, and I'll do a dual channel trace of the signals and take a look at the distributor, see what the input signal looks like going to the computer right now. I'll make a video because I don't have a way of capturing. I got an old school scope, not like modern stuff. So I'll try to make sure I get a video of that actual scope while it's running to see if we can capture the images using Jeff's distributor. Then I'm going to swap out Jeff's distributor, put my distributor back in, and we'll do 2 kinds of tests. I'll leave the oscilloscope hooked up so we can look at the waveforms of the actual engine while it's running, and and if it cuts out, I'll have this as my backup go-to thing to flip. My hope is that if it will cut out, and then when I try to crank it, we'll be able to look at the signal. If it looks the same coming out of going into this computer. I guess it could be a signal that's coming out of the computer. Has to be a problem. Maybe I should be taking a look at the signal there. I don't know. Maybe I need at least a 3-channel scope. You know, 2 inputs and this 1 output to the trigger the igniter. Anyway, it's a perplexing problem. Although, you know, like I said, it did not miss a beat this time. It was perfectly fine. So I might just have to hold Jeff's distributor hostage. Haha, Jeff. But I also have that new crank angle sensor coming, and I will most definitely be playing with that to see how it behaves. I really don't like the fact that I had that couple intermittents where it just stops running. One of the things I was thinking about doing was to take the crank angle sensor. It looks like you could unscrew it from the PC board on the stock unit and kind of open it up and see if it looks like it's dirty, maybe a little bit of trash in here on the diodes, on the light emitting diodes, or in a photo diode. I don't know. Anyway, I just wanted to show you my switch. I thought that was kind of cool. This side is signal to the igniter. This side is negative side of the coil. So you have 2 blue leads. Blue lead from one igniter, blue lead from the igniter. The brown, I didn't have any more blue wire. The brown is what goes to the negative lead on the coil. And of course the positive on the coil was unchanged. It's not switched. There's no reason to switch that. And of course the grounds are not. I didn't switch out the grounds. I mean, both grounds are constantly connected for both the transistor and the igniter. Well, anyway, that's all. Wish I had more report, but it ran perfect. It ran like a champ. More later. Thanks for watching.